Hello everyone, let's talk about modifiers. Let's give definition. Let phi be a smooth function on Rn for n greater or equals than 1, and we put in phi epsilon x, phi x divided by epsilon power n, because our x is in Rn for epsilon greater than 0. So then phi is modifier if it satisfies three requirements, three conditions.
Okay, I found this on the web for requirements for.
The first condition is it should be compactly supported. What does it mean? It means in the given domain, on the boundary of a given domain, this is 0. Like phi, for example, our domain is omega, on the boundary is 0. And second condition, integral of phi x dx in Rn should be equal to 1. So, and third condition, limit phi epsilon x when epsilon going to 0. This is equal to limit fx divided by epsilon power n, epsilon going to 0. This is delta of x. Delta of x is Dirac delta of function, which means derivative of function is f0. Like Dirac delta is equal to 0 if x not equal to 0, and infinity if x is 0, and integral from minus infinity to plus infinity dx is equal to 1. This is Dirac delta. And why we need a mollifier? Mollifier we need to make like approximate function to smooth functions. Okay, one of popular example of modifier is phi x is equal to e epsilon power minus 1 over 1 minus x square divided by in if x less than 1 and 0 otherwise. where in is normalizing, like we need it for normalization. Okay, if you have any question, you can write. One more thing. For example, if we have some phi f function f epsilon, what will be modifier for this function? Sorry, how we can modify this function? We have phi epsilon. We need to do modify in order to like approximate this function by smooth function. We need to modify this one. F epsilon x is equal to convolution f by phi epsilon. We take phi epsilon as before in x, which is f y times phi epsilon x minus y dy in Rn. So if we have function f so we can using this formula to make right modifier of this function. Okay, have a good time.